get started with our first topic, which is understand scalability in Power BI. So perhaps you have heard that Power BI can seamlessly handle trillions of rows of data, but you are not able to accomplish that in your own Power BI tenant. So, working with high volume and large scale data can be done in Fabric and Power BI with the right groundwork in place. And this section introduces considerations for building enterprise scale IT driven solutions. Okay, and you will review the data modeling best practices and Power BI premium fabric features for working with the large data. All right, so let's look into the details of this section. So, one of the key to manageable performance solutions with large data is good model design. And we will discuss model scalability, why it's important, and what tools exist in Power BI to help you and your team accomplish your goals. So, what is enterprise or large scale data? Now, before we talk through scalability, let's define what we are talking about, and it is enterprise scale data. So, it is the data that is massive, complex, diverse, rapid, and valuable. It requires a unified data platform that can handle all the aspects of data analytics from data movement to data science in a scalable and cost effective way. Microsoft Fabric is such a platform which offers a lake centric data warehouse, a serverless integration service, and a comprehensive suite of data engineering and data science tools. So, if you're familiar with working with the enterprise data, it may be helpful to understand that Power BI is the next generation of analysis service. All right, now let's move ahead. Now, what is scalability and why it is important? So, scalability in this context refer to the building data models that can handle growth in the volume of data. A data model that ingests thousands of rows of data may grow millions of rows over time, and the model must be designed to accommodate such growth. So, it is quite important to consider that your data will grow or change, which increases complexity. Now, scalability must be at the forefront in enterprise solutions to ensure flexibility, which means that model needs to be accommodate change. Okay, needs to be able to accommodate change. Then data growth, that means model must be able to handle an increase in data volume with acceptable report performance. And it also reduce the complexity, which means model built with scalability in mind will be less complex and easier to manage. Okay, now how do I design for scalability? So, the best approach to build scalable Power BI semantic models will always be building with the data modeling best practices in mind. Beyond the data model, Microsoft Fabric was designed specifically for enterprise deployments. Now, Fabric or premium capacity offers greater storage capacity and allows for larger individual datasets depending on the SKU. Implementing the Fabric only a large dataset storage feature, it enables data to grow beyond the Power BI desktop's file size limitations. Now, another important consideration in designing for scalability using Fabric is choosing the right capacity. So, you will need to work with your Fabric administrator to determine that which licensing SKU is available to you. If you are having performance issues in Fabric capacity, work first to optimize your model and then work with your Power BI administrator to monitor Fabric capacities. At the most basic level, it's important to understand that premium capacity requires sufficient memory for processing, and you will need to double the amount of RAM to process your data model refresh. So, for example, if you have a 40 GB dataset, you will need at least 80 GB of memory available, and a 40 GB dataset would be best supported by a P3 or A6 capacity, which contains 100 GB of memory. And if you're not sure that which license type your organization has, then you can check with the Power BI administrator. Now, implementing data modeling best practices. So, it is a key to performant scalable data models. And for that, first we can choose the correct model framework. Now, choosing the correct Power BI model framework is at the heart of building any scalable solution. So, the first place to start with your Power BI data model is import mode. So, import mode offers you the most options, design flexibility, and delivers fast performance. You can also use a direct query when your data source stores large volume of data and your report needs to deliver near real-time data. Finally, you can use a composite model when you need to boost the query performance of a direct query model, or when you deliver near real time query results from an import model, or when you extend a Power BI data set or Azure Analysis Service model with other data. So, composite models it combine data from more than one direct query source, or combine direct query with the import data. After that, after choosing the correct model framework, then we will implement the data modeling best practices. Okay, and there are some basic principles to abide by when building any data model. These principles become even more important as data begins to grow. So let's discuss some best practices for import mode. So we always start with the import mode if we can, and we should only bring in the data that we need. So for that, we can remove the unnecessary rows and columns, and we can only process what is absolutely necessary given the business requirements. Also, we can avoid wide tables. Okay, so when we are so for that we should use a star schema in Power BI. And if your source is a beautifully modeled data warehouse, you are a step ahead. And big data is often in wide flat tables, so we can take an advantage of dimensional models for their performance benefits. Power BI it also support multiple fact tables with different dimensionalities and different granularities. So we don't have to put everything into one large table. All right. Now, one of the important best practices is pre-aggregate the data before loading it to the model where possible. Apart from it, you can also reduce the usage of calculated columns. So data transformation, it require additional column, and that should be done as close to the source as possible. Also, you can avoid high cardinality columns. So we can do that by breaking a date time column into two columns, like one for date and one for time. You can also use appropriate data types. So for that, you can use integers instead of strings for ID columns, and you can use surrogate keys for ID columns if necessary. Not only this, but you can also limit the use of bidirectional filters on relationship. Apart from it, you can also disable auto date time, because when you connect to a data table at the source or create your own data table, okay, so disable attribute hierarchies for non-attribute columns. If querying a relational database, querying database view rather than the tables. All right, you can also consider partitioning and incremental refresh to avoid loading data you don't need to. You should also check to ensure that query folding is achieved, because if we know that if query folding is not possible, you have another opportunity to work with the data engineer to move transformation upstream. Now, these were the best practices specific to the import mode. Now, let's discuss some best practices which are specific to direct query mode. So, for that, you can set the relationships to enforce integrity using the assume referential integrity property on the relationships. And this assume referential integrity setting on the relationships, it enables queries to join to use inner join statement rather than outer join. You can also limit the use of bidirectional filters on relationship. You can use only when necessary. Not only this, but one of the best practice is to limit the complexity of DEX calculations, because query folding occurs by default in DEX query, and more complex DEX measure means added complexity at the source, and that will lead to slow the queries. So the need for complex decks also lead back to the key principles of applying transformation as far upstream as possible. Okay, and for that, you may need to work with the data engineer to apply transformation at the source. Another best practice is to avoid the use of calculated columns. Here, transformation requiring additional columns should be done as far upstream as possible, particularly whenever you are using direct query. Another best practice is to avoid relationships on calculated columns, avoid relationship on unique identifier columns, and using dual storage mode for dimensions related to the fact tables that are there in the direct query. So these were some of the best practices that we need to consider. Okay, and now let's move ahead with our next slide. Now, using the large semantic model feature. So for that, first we need to configure the large data sets. Okay. Now, Power BI datasets, it store data in a highly compressed in-memory cache for optimized query performance. And enterprise deployment of an analytic solution using Power BI will likely require Power BI Premium. So, with the large dataset storage format enabled, dataset sizes are limited only by the capacity size or maximum size which are set by the administrator. This differs from the datasets in Power BI Premium, which are limited to 10 GB after compression if large data storage format is not enabled. So large semantic model can be enabled for all the premium P SKUs or embedded ASKUs and with the premium per user PPU. The large dataset size limit in the premium is comparable to Azure's analysis service in terms of data model size limitations. And enabling the large semantic model format enables fast user interactivity and allows data to grow beyond the 10 GB limit. Now, enabling the large data set storage format. All right. So, to take the advantage of large data set storage format option, it must be enabled in Power BI service. So, here you can enable the large data set storage format for a single data set or for all the data sets created in a workspace. Now, how can we enable a large dataset storage format for single dataset? So, in the dataset settings in Power BI service, we can toggle the slider to on and then we can select the apply like it is shown in the figure on the slide. Now, and we can also enable large dataset storage format for all the datasets that are created in a workspace. And we can do it by setting the default storage format for all the datasets created in a workspace in the workspace settings. Okay. And in the settings, we can select the premium and then we can select the large dataset storage format as the default storage format as it's shown on the slide. Okay, so with this we are done with the first section of with the first topic of our today's agenda. Okay, so let's start with our demo of creating and exploring a semantic model. So in this model, we will use Fabric interface to develop a data model over the sample New York taxi data in a Fabric data warehouse. And here we will create a custom semantic model. Then we'll create the relationship and organize the model diagram. And also we'll explore the data in our semantic model in Fabric. So let's first create a workspace. So for that, I will create a workspace inside Synapse Data Warehouse. I'll click on workspaces. So one of the workspace I have already created. So let's just select this one. Okay, so this has been created, but so far there is nothing. So now I will go back to Synapse Data Warehouse homepage and I will create a warehouse. Okay, so warehouse is getting created. Okay, so in the center, we can see various ways of creating, of loading data. So we'll select the sample data. And after selecting sample data, we will load the NYC taxi data in our data warehouse. Okay, so now we can see our sample data has been created. It has been loaded, and we can see what all tables and views already exist in this sample data warehouse. Okay, so now let's just select the reporting tab of the ribbon and choose new semantic model. Okay, so this will let us to create a new semantic model using specific tables and views from our data warehouse, and it can be used by the data teams and the business to build the reports. So let's just name it as taxi revenue. Okay, and now we'll select some tables. So I will select date, geography, trip, and weather. Confirm. Okay, so new semantic model has been created, and how can we verify it? So we'll go to the demo workspace, and here we can see our semantic model that we have just created, which is taxi revenue. All right. So now we'll select the open data model. We'll, and now we will create the relationship between these tables. Okay. And here we can just select pin related field to the top of card. All right. Now we will create a relationship between the date table and trip table using using the date ID column, which is there. And then we'll select the date ID column in the date table, and we'll drag it and drop it on the top of the date ID column in trip table. Okay. So let me just arrange it this way. Date ID column, drag it on the date ID column of trip table. And from date to trip, our cardinality would be one to many. Okay. All right. So we have to ensure that relationship is one to many from date table to trip table. Okay. Now we'll create the relationship to the trip fact table from geography and weather dimensions. So we have to repeat the same steps. Okay. And we have to ensure that relationship are one to many with the one occurrence of the key in the dimension table and many in the fact table. So from the geography table, I will select geography ID, and I will drop it on drop off geography ID. Cardinality would be too many. Okay. And in the same way, from weather, we'll select the date ID and drop it on the date ID. Okay, so now we can see that the relationship between the table has been created. Okay, and we'll arrange the strip table such that it'll look like a star schema. So now our star schema model is complete. Okay, and now let's explore the data. So to explore this data, we will navigate back to our to our workspace, and we'll select a taxi semantic model, taxi revenue semantic model. Now from here, I will just explore this data. Okay, so when I click on explore your data, I will get a pop-up. I'll get a window, and here uh, we can just take a look at our data in a tabular format. Okay, so now we will add year name and month name to the rows. Okay, so to the rows we will add year name and month name. Okay, and we'll also explore the average number of passengers and average trip amount and average trip duration in the values field. Okay, so for that we'll just scroll down, and in the values field, firstly we will select the uh, um, number of passengers. So in the trip, we'll select passenger count. So right now we can see it is showing sum of passenger count. Okay, so we'll see how can we change it to from summarize to average. Then we'll select trip amount, and we'll select trip duration. Okay, so trip duration. All right, now in the values in the data option, I can just aggregate it to average. So I can do the same for all the data that we have selected. All right, so now our tabular data has been is ready. All right, you can just expand it, and we can see all the data in a tabular format. And we can also select the visual at the bottom of the window, and from here we can select any kind of chart that we want to select. Okay, and we can view the result. After this, we can just save our data, save this exploration view to our workspace by clicking on Save button. Okay, all right, demo workspace. right, and now let's check whether it has saved or not. So we'll go on workspace and we can now see taxi revenue exploration. So this was about the demo of creating and exploring the semantic model